Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 9th. Looking at significant wave heights for the North Pacific Ocean, we see an area of seas 19 feet here, just passing over the date line. This is fading. It was a gale off of Kamchatka and has produced swell. Another system starting to organize here in the West Pacific. A tropical system, Songda, developing as well. And yet another system fading out, swell pushing towards the U.S. West Coast. Fall is finally here. Let's do a quick review of what's occurred over the past 5 days. First up, a gale developed on Wednesday off of the Kuril Islands, producing 33-foot seas, heading towards the date line, and then dissipating. Swell from this system has already hit Hawaii. In fact, it hit it fairly solid, larger than expected on Saturday, with waves. There was one buoy reading at Waimea Bay in the pure swell, 10 feet at 17 seconds. Certainly, there were some large waves. That swell is pushing towards the U.S. West Coast right now, bound in for California on Monday, but not as big as one might expect. Another tropical system tried to develop, but only produced a small area, 30-foot seas. This was formerly a tropical system off of Japan. Made a little blip of seas, but then quickly pushed up into the Bering Sea and dissipated. But another gale formed right behind it with, 25-foot seas or so, and through Saturday, and then dissipated on the date line on Sunday. Small swell is coming from that, and then that gets us to our current state. So there is one swell in the water for California, another one behind that, and also for Hawaii, and much more on the charts. Let's get into the details. We'll start our tour with jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their path. We're looking for a trough. This is what a trough looks like right there. This is a good one. 180 knot winds pushing into it. That sets up a counterclockwise flow aloft and down at the surface. And of course, that is the hallmark of low pressure. Low pressure generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, that is the wind, turns into swell. And swell, of course, makes surf. So here we go. We have a fairly healthy, consolidated jet stream. No split here. Just one good, push of a river of energy pushing off Japan, forming into this trough here in the Western Gulf, and let's see what it does. It sort of pinches off here, but more wind starts building back to the west on Monday, and this continues, and there you go. You have 190 knot winds. Again, a bit of a trough. Now, this is not the classic trough. You really want to go sort of a line north-south rather than east-west, but we'll take whatever we can get. Also notice the jet, it splits here, but some of that energy starts moving into California on Wednesday or so, and we'll just roll this out. Look at this, the trough, 190 knot winds. It starts redeveloping on Thursday in the Gulf of Alaska. That trough, look at this, pushing right into Oregon on Friday. More energy here, builds 190 knots off of near the dateline area, pushes off to the east, and yet another Gulf trough is forecast a week out on Sunday, and this looks rather good. We'll go to 180 hours. Now the jet starts looking a little bit softer back here about a week out, but at this point, and notice with that jet pushing into Northern California, this definitely suggests rain and wind for the coast. So our first possible weather producer of the season. Now the question is, will the models verify? Will this really happen? Who knows? As typical, a week out, the models tend to always overhype it, and then things mellow out a bit as we get closer. But this is a good-looking jet stream picture, consolidated, good bit of waviness to it, not flat. That tends to create gales. Next up, we go down to the surface. Surface level wind, surface level pressure. You can have all this stuff in the upper atmosphere, but at the end of the day, it's wind blowing on the ocean surface that creates waves, and that's what we want, especially 45 knot winds. A little pocket of it right now occurring off of the Kuril Islands. There's our tropical storm Songda there. We'll put this into motion. So we get one gale winding up on the date line come Monday with a little tiny, mostly 40-knot winds aimed to the west, building 45 later into Monday, and 50-knot winds. So 50-knot winds will get you typically a pretty good 17-second period swell if they hold for a little bit. Most of this looks 45. Anyway, and that rolls into the Gulf of Alaska. We saw the jet stream flow. Notice Songda here is starting to recurve, forecast to recurve to the northeast, and it's supposed to have pretty good winds. We'll take a look at the details on that in a minute. Anyway, here we end up Wednesday night in the Gulf of Alaska, 35-knot winds over a large area with one small patch to 45 knots, building to 55 knots on Thursday, and rolling right into the U.S. West Coast. Songda right behind that. Look at that, 55-knot winds. That's a storm. 50-knot winds or greater are a storm, with another storm right behind it. Songda going extratropical, forecast through the Gulf of Alaska into the weekend, pushing into the Pacific Northwest, and then things settle down a little bit. We'll have to see what happens beyond that. The models suggest more tropical activity. This is an active pattern. This is what we want. And the interesting thing is, one would typically say this is would be driven by the active phase of the MJO, the Madden-Julian oscillation. But as we get into the details there, we're not certain that that is happening either. So it's kind of a mixed bag, but you take what you can get and run with it when you can. So we know there is 2 swells already in the water pushing towards Hawaii and the U.S. West Coast. And here we go. Here's our significant wave heights for Monday. Seas building 25 feet, 28 feet, 34 feet, quickly up to, 38 feet. We'll just pull this down just a little bit more. There you go. Here's max sea height, and the little X denotes where it is. You actually have the coordinates here. Winds 48.8 knots in that area per the model. Just roll this out. Whoa, and that builds up to almost 40 feet and almost 50-knot winds there. Falling southeast right at the U.S. West Coast. That certainly seems like it would be a good swell producer, sort of more sideband swell for Hawaii, directly aimed at the Pacific Northwest, and from California, even into Southern California should see some energy from this. Then that continues to percolate, tries to get a little bit energy. Notice Songda back here making its approach too. A second pulse on Thursday. Oh, now we're talking 48-foot seas in very close proximity to the coast. Given that, one would think probably massive, ugly storm surf. But this would do good for Southern California. Kind of a north angle, but you know what? All that size and energy will wrap right in there. They shall get a taste of fall as well, and it'll be full-on winter if this verifies in California. Anyway, Songda then makes its approach into the Gulf of Alaska with 39-foot seas on Saturday, supposedly up to 40-foot. And then hitting into the Pacific Northwest with piles of energy left behind there. And and that gets us to the end of that run. So, no shortage of activity suggested. Good. It's about time. It's been the better part almost 2 months without any real surf. So, get yourself prepared. We're going right from summertime deep into winter in the period of a week if the models are correct. And here's a quick look at Songda right now here in the far west Pacific. What would this be? Southeast of Japan. Winds at 55 knots, but forecast to build to 90 knots. So that'd be somewhere in the 110 mile an hour range on the 11th. So right here as it's making its turn to the northeast and then accelerating, notice the difference, the relative short difference between reporting periods here, then accelerating off to the northeast, dropping, of course, to tropical storm status, and from there going extratropical. We'll see if that really happens, but this looks very encouraging, imparting more tropical energy into the atmosphere. Good news, that only can create surf. We'll just take a quick look down in the southern hemisphere, wave models. Nothing is really forecast. We see little pockets of 20-foot seas or so. That just won't cut the grade, especially when there's so much energy much closer in the North Pacific. And here, there we are a week out, and really nothing. Next up, we take a look long-term, our long-term outlook, affected first by the Madden-Julian oscillation, shorter oscillation in the 4 to 6 week time period, and then of course La Niña, which will go through the entirety of the winter, the transition from El Niño to La Niña. First off, we take a look at winds in the Kelvin wave generation area and across the equatorial Pacific. New Guinea here, and over here, beyond here is Ecuador. It is the equator, and it's an area really just 5 degrees north and south of the equator that starts at about 170 west right here and goes over to about 135 east, and this is the area we call the Kelvin wave generation area. Now notice all this data is from actual buoys, the TAO buoy array strung across the equatorial Pacific, used for monitoring El Nino. We see strong or solid easterly trades across the entire Pacific, not quite as strong in the Kelvin wave generation area. Then we go look at anomalies, differences in normal for this time of year. We see these winds are pretty typical, not either an easterly or a westerly anomaly component, till we get to the Kelvin wave generation area, and it suggests easterly anomalies, winds blowing out of the east a bit stronger than normal. This would suggest the inactive phase of the MJO. Now here's what's really interesting. We see all this storm activity blowing up in the North Pacific, even while the quote-unquote, it appears that the inactive phase of the MJO is in play. Let's go dig a little deeper and see if that is in fact the truth. So here's another look, wind anomalies, zonal wind anomalies up at 850 millibars. That's about 4,400 feet up in the air, but it's a pretty good proxy for what's going on down at the surface. Kelvin wave generation area, here's the date line here. So this is the whole world on one chart. Kelvin wave generation area runs from about here, from here to about somewhere over in here, and the blues are easterly anomalies. This was what we call the inactive phase of the MJO. It started on about the 11th of September, and you can see nothing but blues and purples here. But notice right about now, it looks like the inactive phase of the MJO is dying, and that syncs rather well with the latest storm cycle, this building storm cycle forecast for the next week. Now notice there's still some easterly anomalies. If this was a real active phase of the MJO, you'd expect to see yellows and oranges all through here, but that's not forecast. Still, it's mainly a pullback of the inactive phase of the MJO, and maybe that is helping fuel some of the storm development. Outgoing long wave radiation. That is another way to monitor the presence of El Nino, the active phase of the MJO or inactive phase. Blues suggest less sunlight reflectivity, negative numbers there, which suggests cloud cover, which suggests the active phase of the MJO. The yellows suggest more sunlight reflectivity, high pressure, and the inactive phase of the MJO. So the statistic model says that some weak flavor of the active phase of the MJO is control. The GEFS, that's the ensemble version of the GFS model, says no, just a completely neutral pattern, and over the next 2 weeks, if anything, the inactive phase is going to move in. Phase diagram charts, these are used for locating the active phase of the MJO. The big dot is where it is. So this is, you call it the cone of death or whatever you want to call it. Basically, consider you're looking down on the northern hemisphere, looking down on the North Pole, and the active phase of the MJO, when it's strong, moves counterclockwise from the Indian Ocean over the maritime continent like New Guinea and Bali in that area, over the date line into the West Pacific, East Pacific, over U.S., and then into the Atlantic and back into the Indian Ocean. And the period over the Pacific is anywhere 4 weeks active, 4 weeks inactive, or 4 to 6 weeks. But right now, because the active phase is right smack in the center of the cone of death, then basically there is no real footprint for the active phase. It's extremely weak. The other model here, the GEFS, suggests the same thing, but the forecast for the next 2 weeks suggests, yeah, maybe it'll strengthen just barely, but it's going to be over the, the Atlantic and Africa, and will have no impact on the Pacific. And then finally, the CFS version, or the CFF's model's version of what's going on. Again, 850 millibar winds. Now this goes from past history on the bottom to current history, or the forecast at the top, and the Kelvin wave generation area right here between these two, date line here and 120. And so here's where we are right now, and you see a little bit of easterly anomalies. You see a little bit of westerly anomalies forecast. Let's just overlay what the model says is going on. It says the active phase of the MJO is going on. So you know what? We're going to side with this model more than anything and say, yes, the active phase is in play. It is extremely weak, but it's doing enough to help push the storm track, and that is probably what's been responsible for the gale pattern of the past week. Supposedly, when did this guy get started? September 23rd or so. So, you know, I don't know that it really did, but their tendency is to favor storm development through, about the 18th, 19th or so of October. Then supposedly the inactive phase is to come in, and notice a little bit of easterly anomalies are forecast setting up through about, the first week in November, and then the models suggest a very much larger active phase of the MJO with lots of westerly anomalies. Of course, this has been on the chart for a while. It is holding better than we thought it would. We'll see whether it actually, like 3 or 4 weeks from now, see if this is still here or whether it just keeps getting pushed off. If this were to happen, and of course it's supposed to happen in the November, December-ish time frame, that would do a lot to help promote storm development. Anyway, here we go. The thought is right now, weak active phase of the MJO is occurring over the Pacific, and that is what is responsible for producing the storms that we're seeing on the charts and those that have already happened. So we've talked about the MJO and its contribution to the storm track, but let's go look and see what's going on longer term, and let's take a look at subsurface dynamics of the ocean. West Pacific here, East Pacific here. Again, the same buoy array, the TAO buoy array. The X's are sensors on the buoy anchor lines, and they help determine where hotter than normal, or where the temperature balance is in the Pacific. Most of the warm temperatures, as we see, are in the West Pacific, and cooler temperatures in the East, a very shallow thermocline. This is typical of La Niña. During El Nino, all this warm water starts migrating over here, and as last year we saw a lot of much warmer temperatures over here and cooler over here. Now we're in the reverse, and this is pretty typical. Anomalies, differences in normal for this time of year. We see a generally cool water regime, subsurface down about 150 meters the whole way across the Pacific, and at the surface, warmer temperatures, 1 degree above normal in the West Pacific, and pretty much neutral here off of Ecuador out to about almost a point south of Hawaii, and then between Hawaii and the dateline or so, a little bit below normal temperatures, about 1 degree. This is typical La Niña. Putting that in perspective, this chart, upper ocean heat anomalies, the upper 300 meters, and we're going back to November last year. Here you can see a Kelvin wave, warm water working its way from the West Pacific to the East Pacific. That was Kelvin wave number 5. The final Kelvin wave of that big El Nino in the January-February time frame. And here's the cool water that was over in the West Pacific. Then all of a sudden, it starts flushing to the east in April, and that is the onset of La Niña. El Nino dies here, and here is La Niña. We thought it was going to set up quite strong, but as you can see now, it's here, but it's not particularly robust, though it seems to be getting, you can't tell it from this chart, but when you look at some of the surface data, and we'll look at that in a second, it seems to be getting a little bit better of a toehold. Again, another way to look at subsurface data, you can actually infer it from looking at the surface. This is the JSON-2 satellite making multiple passes over the ocean surface. You strip out all the waves, strip out the wind chops, strip out the tides, and then you get this pattern that shows, and compared to normal for this time of year, you see that the sea heights are actually 10 centimeters below normal right here. That is an indicator of cooler than normal water at depth. Cooler water contracts and actually makes a weak little divot in the ocean surface here. And it is just this area right here on the equator that we're interested in, the Niño 3.4 region. Niño 1.2 is right here up along the coast of Peru. And we see pretty normal, certainly not warmer, but not particularly cool. But the deep hole here, or deeper hole, is right in the core of the Niño 3.4 region, which runs from 120 west to 170 west and 5 degrees north and south of the equator. So this correlates pretty well with what we're seeing in the other charts. Now here we go. Here's a satellite view, actual surface anomalies, differences in normal, high for this time of year, high res data. We see a little bit of cooling trying to set up here along the immediate coast of Peru, but the obvious thing is warmer than normal temperatures. It's like El Nino hasn't completely dissipated in this area, and we've had a little push here in the past couple of days of cooler water trying to radiate off the Galapagos here and off to the west, but not making much headway. This warmer than normal water temperatures seem to be sort of holding things in check, which is a good thing. And La Nina is all focused from 120 west out here. So yes, that is the prime area for measuring La Nina, but if it was really strong, you'd see a clear signal here off of Peru and the Galapagos and Central America, and we're not seeing that at all. So we're calling this a weak and westward displaced La Nina. The trend for the past 7 days, you actually see warming here building over the Galapagos. 5 days ago or so, it got markedly cooler here, and we thought La Nina was going to pulse, but all of a sudden that seems to be chopped off. Again, we look over here off of Africa, and we see this warming trend, and this normally is what we use to look to give us a long lead of what's going to happen in the Pacific. And if the trend is staying warmer here, you might get variations, but they're not going to be as deeply indicated as if it was getting cooler over off Africa. Anyway, we've seen this pattern, a mixed warming cooling pattern further out. No change in that, mainly in the area where we're seeing La Nina from 120 west out to about 170 or so. And then just here's the overview. Temperatures, you notice lots of warmer than normal temperatures, not only in the Pacific, but also in the Atlantic. But the focus here is the main cool pocket. This is what La Nina looks like, but typically it starts over here. And you notice, yeah, there's a little bit of coolness here. And this is much larger than it was last week when we did this. So there's been a little bit of a pulse of La Nina, and the cool upwelling eddy has made a little bit of progress here off the Galapagos, but not much, and all the data suggests that this is probably going to shut off again, and the focus will remain out here. The more La Nina remains westward displaced out south of Hawaii, probably the better in the long run. High pressure would build in the North Pacific north of this cool pool, and the storm track would come off of Japan, then rise over Hawaii, and then dip through the Gulf of Alaska, and that's a lot better than if La Nina was over here and high pressure was just locking down the entire eastern half of the Pacific. That would make it very difficult to get swell into California and rain, for that matter. And Hawaii might not do so bad because they're just closer, but if you can get the storm track closer to you, then that increases your odds for rain and also surf and snow and all sorts of other good things. So we've talked about the MJO, we've talked about La Nina and El Nino, but let's see what effect La Nina is actually having on the atmosphere. This is the Southern Oscillation Index. It measures the difference in pressure between Darwin, Australia, and Tahiti. When the daily index is consistently negative, that is one way to look for, or an indicator of the active phase of the MJO. We don't really see that here, even though the active phase of the MJO very weak is indicated in other sources of data, but we have positive numbers that really suggest the inactive phase of the MJO. The 30-day running average has been, well, here we go. It was 7.19. It's 13.32 now, down a little bit, but not much. I mean, we had a peak at 13.82 there. So basically, we're sitting pretty much in the positive side, which certainly indicates the inactive phase of the MJO. And then here, the 90-day running average, it was 5.05. Now it's up to 8.18. That suggests also the inactive phase of the MJO and the onset of La Nina. El Nino would drive all these numbers negative. Here's the 30-day Southern Oscillation Index graphed out last year. Here is our El Nino. You can actually see the pulses. Here's the active phase of the MJO, inactive phase. So you can see the pulses of the MJO, but you can also see the trend was steadily downward, well into negative numbers. This was the peak of El Nino back in last fall, last winter, and then the onset of La Nina and the move into positive territory. We're kind of plateauing out right now, and we're kind of hoping that's where we stay, that this doesn't go more into the positive realm. But considering the strength of El Nino, normally you get an equally and opposite reaction, a strong bounce back into positive range. But we're not seeing that at the moment. And typically when you make that the transition from El Nino to La Nina, it's pretty marked and pretty strong. And yes, we're seeing it, but it's not overwhelmingly impressive. We think that is because the PDO may be having a dampening effect, the Pacific Decadal Oscillation. We'll talk about that just in a second. And one other measure, the ESPI index. So again, we're measuring not pressure, surface pressure, but total precipitation north of Darwin, Australia, and then north of Tahiti. The current index is minus 1.66, which suggests there's less precipitation in this area than normal, which would be expected during a La Nina sort of situation. During El Nino, the numbers go positive. You have more precipitation here. So this indicates that La Nina is in play, but not so strong. So let's talk about that for just a second. Without getting into too much detail, we're just going to do a quick overview. Pacific Decadal Oscillation, it's more of a theory yet than a confirmed hard science, but it suggests that the Pacific goes through oscillations that are, I'll call it warm and cold, and that those periods last 20, 25 years or more. Here we are, and we'll sort of zoom in here, see if we can do this. So looking at data, we're not going to go too far back, but let's go back into the 1930s and 40s. We see the index was generally on the positive side. That would be warm. And then when you get into 1948, notice things really dropped off, went negative. And yeah, we had a little bit of a warm blip there. But from, when was that? Let's say 1945 till, you just go and go until somewhere here in about the 70s. It was negative. This suggests, these negatives, when you go blue, it's like long-term La Nina in the Pacific. When you go warm, it's like long-term El Nino. Now, that's not saying it is literally an El Nino, but it says that it suggests that the tendency is favorable for El Nino and storm development. And when you get in these down things, it's more like the tendency is favorable for La Nina, and that would infer droughts in California. This would infer more water in California. So anyway, you got into the late 70s, and then we went into a warm phase that went on until 98, and then we had a massive El Nino. And no, see, there's still little bits of, there's dry years, but they're not the long-term trend. There was like almost 30 years there of favorable for precipitation and warmth. And then with the big El Nino of 98, boom, we went into this again, into a hole, this drought thing that's been going on through 2014. Now, the theory is, or the speculation is, that this El Nino, now this is a rather short period from 98 to 2014 or so. So what is that? I don't know, 16 years or so. That would be a relatively short inactive phase of the PDO. But the thought is that we're warm, and that maybe we're going, and you can see right there, there's just the little bits of this La Nina beginning showing up on the index here. But that maybe if we have tripped and moved into the warm or positive phase of the PDO, that might help explain why this La Nina is so weak and displaced and off to the west. Too early to know. We're going to need a couple of years. You notice these cycles here. I mean, you have cold cycles in the middle of a warm cycle that go for a couple of years. That's also to say you could have warm cycles that go for a couple of years in the middle of a cold cycle or a cold phase of the PDO. So unknown, and it will be probably another year or two before one can definitively say. But the fact that we had this El Nino and then we didn't bounce right back into some deep hole of La Nina suggests that maybe we're starting to turn the corner. If that were to be the case, we could go for 15, 20, 25 years in a pattern that's much more favorable for storm development, precipitation in California, and also for surf production in the North Pacific, both in the summer months and in the winter months. But anyway, we'll see. That's the thought. But bringing us back to reality, back to the present day, One swell in the water already hit Hawaii, bound for California. Another swell in the water, bound for Hawaii and also California. Both of them long-distance swells from very far away relative to California. Long waits between sets, 3,000 miles of travel time. Might get a good number of waves in a set, but then you'll sit for 20 minutes and there won't be anything. But then looking at the models for the next week, things are supposed to get much more active in the Dateline and Gulf of Alaska. Multiple storms, and by storms, literally storms, 50, 55 knot winds, probably rain, weather, all kinds of stuff. So you have to pick and choose where you're going to surf, but maybe we even get some snow in the mountains. That would be a good thing. And then beyond that, not quite sure. The MJO is active right now. Suspect it will go inactive at some point here, and then we'll fall back into a hole for a little while. But then the long-term hope is that we'll move back into the active pattern come November-ish or so, mid to late November, and then we could be in good times again. So that's it for this week. Swell on the way. Make the most of it. And maybe a lot more swell in the next week or so. That's it. We'll do it again next week. Same time, same channel. Thanks for watching.